There we go. Hopefully that's better. Okay, sorry about that. Good morning, good afternoon, good evening, good night if you're watching from North America. Hi, I'm Aaron from Solace. And yeah, thanks for tuning in. I think this is week number 4, I think, that I'm doing this. So yeah, hey, thanks for being here. All right. I do these weekly on Tuesdays at noon Singapore time. What is that? 2 p.m. Sydney, Melbourne. 9:30 a.m. in India. Happy to answer your questions. We're going to be talking about all things Solace, mostly developer, Solace Dev. But if you're an admin, you're doing ops, I'm happy to answer questions about that. I love talking about monitoring. I love talking about production deployments. But mostly I'm here in the role of the developer advocate to help promote Solace for development. So yeah, thanks for being here. I'm going to go ahead and switch screens here. Places to ask me questions. Hey, so if you wanna ask me a question live, post it into the Twitch chat. Happy to answer. I'll keep an eye on that. I'm also watching our Twitters at Solace Devs. I'll keep an eye on that in case anybody tweets me anything from there. Just say hi if you want. I'm hoping that every week, we get a couple more people tuning in for what should hopefully be an informative hour. I hope. I don't know. Yeah, here to answer your questions. So I am going to be watching Solace Community as well. We're going to go through some questions there. Take a look. I am going to talk about something that I spent a good amount of time on yesterday during one of my developer workshops with a customer. And that was specifically around queues and the difference between topic endpoints, and queues, or queue endpoints. There's always confusion around that in the Solace land. Whenever we work with new customers who are not familiar with Solace technology, often they kind of run into these kind of things. There is some good documentation out there that helps explain it. I might do a little bit of whiteboarding, maybe. Do I have my whiteboard app open? No, I have to get that sorted out here. Good old Microsoft Whiteboard. I've used that once or twice. Let's see. I'll do that later. Okay, so yeah, head over to Solace Developer, Solace.community. Ask me questions there on Twitter or on the chat. Like I said, I'll try and keep an eye on things. So let's go ahead. What are we talking about this week? Well, first of all, announcements. So last week I did a live stream event, live stream coding, quote unquote, coding event with my colleague Heinz on Thursday. We streamed it on Twitch and on YouTube. And it was all about connecting Kafka to Solace. So using our now productionized versions of the Kafka connectors, both source and sync. I walked through basically how to install Kafka, how to get it running on your local host or on a server, and then installing the Kafka connectors for Solace, and then demonstrating some of the connectivity there by ingesting some data from one of my demos, my bus demo, if you've seen that. So if you want literally a handheld walkthrough on getting started with Kafka and then plugging that into Solace, check out the link. It's on YouTube. I think it's called Extending Kafka with Solace PubSub Plus or something like that. So that was last Thursday. That was great. This week, what is in store for our live stream? Okay, so tomorrow, Wednesday, some colleagues in the States, I believe this is my American colleagues. There are 2 sessions. Great. We're going to be demonstrating how to build Battleship, the game Battleship. You sunk my battleship, A4 and B6, on how to build that using TypeScript, Java, and PubSub Plus. So tune in for that. It's going to be a kind of since it's one of these online developer workshops, it means we're going to be following a CodeLab tutorial. You can find all of our CodeLab tutorials at codelabs.solace.dev. Wow, that's really zoomed in font there. There we go. And, yeah, we're going to be following along this one. So that's pretty exciting. And in 2 weeks, I am going to be doing a CodeLab workshop as well for specifically the Kafka connectors, the source and sync. So what we did during the live stream, I'm going to take that and formalize it into a CodeLab. So in case you don't want to just follow along with a video, we're going to build a CodeLab tutorial on how to walk through that and get started. So Pretty straightforward. It really is. You know, it's just kind of downloading the jars, building them, and copying them into the right directory inside the Kafka libs. Or if you're running the Confluent version of Kafka, just sticking it into the right folder. And things just work, you know, things just work. It's pretty straightforward. And I was actually getting pretty decent performance just on my local host. So I was quite impressed with that. Yeah, so tune in tomorrow, Building a Battleship, sign up for it. There's 2 sessions, 9 a.m. and 9 p.m. EDT. So what is that? That'll be 9 p.m. This will be 9 p.m. in Singapore, and then 9 a.m. to 11 a.m. the next morning. So July 16th, which is what, I guess that's Thursday morning. So it's Thursday morning Singapore time, 9 a.m. to 11 a.m. how to build this. So I'm going to be tuned in for that for sure. That should be pretty good. I think I have my aircon servicing guys coming over Thursday morning, so I'll have to be on mute. Okay, so that is what's happening this week. Check those out. Every week we are presenting something live, whether it's a workshop, a live stream coding event, or something along those lines. So be sure to check out the community. We always have at the top here kind of the posting for it. Or another great place to keep up to date on all things is solace.com/events. This will list all of the upcoming events that we are arranging, organizing. There's my colleague Phil. Let me zoomed in here. What do we got? Yeah, so this is the one that is going to be presenting. This is actually another one that Phil, this guy, is doing with another company called Axway. I'd actually just signed up for this. So taking Axway to do APIs, and we are doing a joint webinar on how to integrate Axway with Solace and some of the value prop there from having a combined thing. So if you're a big user of REST APIs, REST API management, you're probably familiar with Axway as a product, check out this webinar. It is going to be Wednesday. This is Singapore time. I'd have to check my email to find out exactly what time it was at. I want to click on things. Does it say here? Add to calendar. It's sometime on Wednesday morning in Singapore time. So this would be kind of Tuesday night if you're in North America. Anyway, okay, let's get on with it. What are we talking about next? Give me a shout out there if you're out there. Say hello on Twitch chat. Send me a tweet. I'm just going to refresh the tweets here. Just make sure there's no questions that are being asked. Welcome if you're new. My name's Aaron. I'm from Solace, and I'm here to answer questions for an hour. Okay, so let me see. Let's look at, this was actually started recently. So this is one of our developer community managers, Trish. She's new to Solace, just not too long. Welcome, Trish. She started off this kind of introduction thread. This is great. I need to actually post myself onto here. People on the community is trying to put a name to a face, where you're from, what's going on. Tamimi, another one of my colleagues, developer advocate based in Ottawa. That's my manager, Mark, based down in Florida. So yeah, I'm gonna have to post myself in here and kind of say hello. Oh, here's Hong. Hong is also one of our developer marketing guys based in Ottawa. So Ottawa is where Solace is from. That's actually where I'm from, but I'm in Singapore right now. So I've been living in Singapore for a couple of years. Anyway, if you're new to Solace community, check that out. Those are some familiar faces. Hopefully we'll get some other Solace people to tune in there. Okay, let's take a look. Hey, here's a new question with 0 comments. Let me do this real time. Rather than review something, maybe we'll see if I can actually answer it right here. All right. It's Spring though, Spring Cloud Streams. This is Mark's domain. I really got to start learning. I'm a Java guy, but I don't know actually that much about Spring, which is really too bad. But let's see if I can answer this. Following is a sample bean to receive messages from a queue, right? Okay, how can I get the topic name through which the message came into my queue? You check the destination. The queue is configured to receive multiple topics, and based on the topic, blah, blah, blah. Based on what the topic is, you're going to have different processing logic. That is very common. I was able to get the topic name using getDestination.getName. That is correct. When I was using the sol.jcsmp library in the Spring Cloud Stream library, how can I get this information? Oh, that's not exposed, eh? That's interesting. You know what? I don't know. That should be though. And if it's not, if there's no way to actually get it, that is not great. I tell you what. Okay, so let's do a little poking around here together. Spring Cloud Streams Kafka. Spring Cloud Streams Rabbit and Spring Cloud Streams Kafka. No, I want Spring Cloud Streams Solace, please. Let's check this out. Where are we going to find documentation for this, though? I don't know. Okay, let's check that. And Spring Cloud Stream API. I need to find the docs. Is it in the docs or is it in our stuff? I don't know. I don't know. Reference guide. Here. Blah, 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 blah. I should really download this and play with this. There's actually, it's, from what I've seen people just take this thing, integrate it, and within a few minutes, literally minutes, they are doing cool stuff with Solace messaging because it handles all that boilerplate code kind of for you. There has to be a way to get at the original message and get the topic of the message. But yeah, Matthew Sue, you're totally right. This is exactly how you would get this if you were using JCSMP. Yeah, there's got to be a way that maybe you can cast this somehow. Maybe that would be the way to do it. I don't know. Tell you what, I'm not going to spend time on this call to just go and debug this, but that is a great question. And if it's not exposed, we're definitely going to make sure that we add a feature enhancement to expose that, because that's kind of important in my humble opinion. So yeah, all right. Not a great answer there. I wish I knew off the top of my head. You know what? I'll give it a few minutes. I'll give it a few minutes. Let's see if we can do this. I'm going to download this. All right. Let me open up a new terminal here, and we'll put it on the right screen. Where's my? All right. What was it called? It was called. I can't see. I have to move this. All right. Unzip. Spring. Cloud Stream Binder. Let's take a look here. Where would I go looking? There has to be an easy way. That's all fine. That's all fine. All right. All right. I don't want to spend too long just kind of poking around randomly on a live stream because that's kind of boring. But I will see if we can figure this out really quickly. Well, moderately quickly. Maybe so. It has. I guess it has to be in. Well, tell you what. Let's do this. It was called message, right? That's the original consumer message. So. Okay, so that's all right. Stream binder. Main. Java. Grep -r for message star. Messaging channel. All right. Hey, if somebody's out there and knows, if anybody that's out there knows Spring Cloud Stream Binder, I would be happy to find out. Anyway, you know what? This is going to take too long. I'm not going to be doing this live because that would be way too boring to be just sitting here watching me look for this, poking around inside the code. How big is this class? Not that big. Raw message. Okay. So instead, let's go to that. Look at that core section really quickly. Green stream, core, source, main, Java, grep, our message. So what we're doing, I'm really quickly trying to look through to see if I can find an answer to Matthew's here, Matthew Sue, about how to get at the original message. Look at this. Where are this? Let's check this out. Vim, util, XML. People always see our Java API, our JCSMP API, and look at all these XML words and like, why? I don't want to do XML. When you see the word XML in the class name or the object name, just ignore it. This is old school legacy stuff from way back in the day when Solace used to do content routing. So back in the day, we used to do content routing on XML documents, as well as topic routing, which we still support today. Topic routing based on routing on topics with wildcards and hierarchies and everything. And all of this XML nomenclature is around from the dawn of time, from the dawn of Solace. So this is why we're building a brand new Java API that is going to be rolling out pretty soon in the next couple months. And it's going to be an update, a massive update, same functionality, just much more modern. And it's going to get rid of all these XML words, all this old legacy stuff. So, okay, so message. Message is that a Solace message? It's this kind of message. That's what I was looking for. Okay. So we're going to see. Get headers, get payload. Get headers, get headers. Is there not a header that tells you what the destination was? Or is this only the actual kind of the application properties that we call them in Solace? Error channel, replay channel, timestamp. Gosh, there has to be a way to get the original topic. Tell you what, I'm not gonna spend any more time on this. We'll get Mark to check that out, and we can answer it. Now, if you're wondering what we're talking about here, this Spring Cloud Streams, on our GitHub page, we have examples, github.com. So I wonder if it's in, let's see, products. Let's check products. I'm not sure if it's in Solace products or Solace labs. So Solace has two main GitHub repos for kind of where we put stuff. Besides our samples, we have a third GitHub repo for our samples. Oh, it's right here. Spring Cloud Stream. Solace Spring Cloud. Now this is probably, is this Spring Boot? There's Spring Cloud right there. Oh, there's multiple branches. Here's the binder. I don't know which one is the correct one. This is the one I was just downloaded and take a look at. Yeah. So this is where you can basically, if you're using Spring, this is where you come to basically integrate Solace with Spring Cloud Streams, and get that working. It's so easy. It's just like I said, you add some annotation to your your classes. It basically then, you know, it runs that method every time you get a message or when you send a message. It's super easy to get up and started. So yeah, Solace products and the Spring Cloud Stream binder is where you want to be going. But yeah, anyway, good question. We will find out the answer to that soon. Okay, let's keep going. What time is it? Wow, it's 12:23. I spent way too long just kind of looking around that. Matthew's already asked another question here. Okay. Yes, this was the one that I did. Past event recording available. So yeah, if you're wondering where the recording is for my particular live stream, here it is. Oh my gosh, there's my topic versus topic video. This often comes up, you know. I talked about this quite a bit last week, was the difference between topics in Solace and topics in Kafka. Check out that video, go on YouTube, search for it, you'll find it there. I kind of go through everything. Okay, you know what? So yesterday I had a developer workshop with a customer, and we spent a good amount of time on the difference between what a topic was, what a topic endpoint was, and when you use a topic endpoint and when you use a queue. You know, typically people know that for non-persistent messaging or in Solace direct messaging, you use a topic, you publish on a topic, you subscribe to a topic, and that's all for non-persistent. But when you move into persistence, you know, a lot of other messaging broker products, event broker products, you know, you need to use a queue to do persistence. And the same is true for Solace. However, that's on the consumer side. Consumers want to connect to queues for their persistent storage. But publishers can still publish on topics. You can publish on a topic with the delivery mode of persistent, and that allows your message to be guaranteed, you know, from the point of view of the publisher into the broker. You know, the message is retried if there is a problem, such or the network goes away. You know, you have a HA failover in the broker. The message will be resent automatically. And then inside the broker, you configure this topic to queue binding or topic to queue mapping by adding topic subscriptions to queues. This is by far a standard best practice in Solace. So you know what, I'm just going to go ahead quickly and pull up PowerPoint, and I'll show you the deck that we were talking about yesterday. Because it's actually we talked about this for about 20 minutes, and so if people are out there wondering kind of how you do persistent messaging in Solace, what is the best practices? You know, you've seen these things called topic endpoints. Do you use them? Is that what you need to use for persistent messaging? Is this going to share? Let's see here. I need to share it to my second screen. One moment, please. Presenter view, yes. Why aren't you working? Minimize that, minimize that. No, hey, so. My presenter is on the wrong screen. That is really strange. Give me a second here, everybody. I am trying to figure this out. Maybe it's confused about which monitor to use. Monitor is this one. All right. See if that's going to work. It's showing it on the wrong screen. That's really annoying. Always some technical problems, eh? Always a few technical problems. Let's I'm gonna quit PowerPoint. I'll just restart it. Try one more time. And take a look. Give me 2 seconds. PowerPoint. It's actually the first time it's ever happened, where it's not actually sharing it on the right screen when I do a presentation. All right, come on now. Here we go. Is it gonna work? Nope. My life is, my life is never easy. Okay, so tell you what we're gonna do. We're just going to drag this up here. That's what we're gonna do. Because that is easier than messing around with trying to get it to work. So, where are we? Solace queues. So, here's the basics, right? So, if you're doing non-persistent messaging, you publish on a topic using direct delivery mode. You subscribe to a topic directly with your client application. You add, in the consumer, you add a subscription. No, in the session, you add a subscription. And that's how you do it. I want to quickly pull up a really quick example. You can always check out, if I'm a Java guy, of course, so let's do Solace Java JCSMP. Nope, Solace samples. There we go. Go into our samples here. Vim the topic subscriber. Right, this is right at the bottom here. We add our topic subscription. We start the consumer. Here is the consumer, where you basically specify the message receiver, what happens when you receive a message. And the topic was defined right up at the very top, right? So in this example, we're only subscribing to one topic, but of course you could subscribe to multiple. But if you're doing persistent messaging, the best practice is you configure a queue, you add topic subscriptions to that queue, the consumers bind to that queue, and the publishers, producers, publish on topics, but using the delivery mode of persistent. That is our standard best practice. But what a queue actually is, most people understand it to be a buffer, a temporary persistent storage on the broker. You can use queues in a point-to-point fashion. This is very JMS-y. People that come from MQ, they understand that this is point-to-point connectivity. The problem with point-to-point is that it's quite limiting. If in the future you ever need a second recipient to receive a copy of that data or a subset of that data, it's difficult. There is ways to kind of copy a queue from one to another, but it's not how it should be used. This by far is the best practice in terms of Solace usage on how to do persistent kind of delivery. It's publish subscribe. Almost everything should be publish subscribe when you're talking about asynchronous delivery. Even if you only had one consumer in one queue, this is essentially still point to point, but it allows you the flexibility in the future to add multiple consumers. So you have your queue configured here, Q1. Your consumer is bound to Q1 as their persistent storage, and you add topic subscriptions that will attract topics that are being published on by the producers. So the producers are publishing on whatever topics are belonging to that particular piece of data. Again, topics in Solace are hierarchical. They can be A/B/C or training/topic/Aaron/today's date. It could have a GUID in the topic, to help you easily identify the publisher for that data. If we're talking about connected cars, for example, the VIN number could easily be part of the topic hierarchy, and then you can add ACLs and restrictions around who's allowed to publish on which topics. All that kind of interesting stuff is available and possible because Solace has such a complex and feature-rich way of doing topic routing. So you configure your queue, but rather than publishing directly into the queue as as is here, can I go back? No, I can't go back. Come on, slideshow clicker. So here, publishing directly into the queue, you can address your message to be publishing into Q1. That's point to point. Instead, publish on a topic. You have your queue configured to subscribe to that topic or a subset of it, and then the consumer will receive it. And if in the future you ever need to publish to multiple, you need to have a second consumer receive a copy of that data, or a third or a fourth, all you need to do is create another queue. You add the same topic subscription, or whatever subset of that topic subscription that you want, and now the second consumer will get a copy of that data. And so this allows you to scale things without actually impacting the original actors in the event flow. So let's say, this personally, right? I had a demo. Where I had GPS data being published by a little Java application, right? Simulated GPS data. I then had a consumer that was a map display, and it was rendering the data, GPS data, and that all worked fine. But then I came along and I said, okay, I want to actually pipe this data into some analytics, right? I want to add another consumer to this data. Now, if this code was old and maybe I'd lost it or I didn't want to change it, adding another consumer for that same data could have been, kind of challenging. I would have had to have gone and changed the producer code to double publish once to the map and once to the analytics. But because it was using topics, how easy is it to actually add another queue, add a subscription to that queue, And now my analytics application is also receiving a copy of that data at the same time as my original map data was, and the map and the GPS publisher didn't have to change at all. I didn't have to add extra plugins. I didn't have to add any extra destinations as to where they're sending their data. It is just publishing on a topic, and I can now get copies of that data for free by just adding more subscriptions to that data. How powerful is that, right? And because Solace is all pass by reference, even if there's 100 queues with a copy of this message in it, it's only being written to the disk once. So a queue is persistent storage in Solace. It allows you to, it keeps a copy of everything on the disk, and because it's passed by reference, only one copy of that message will be written to the disk. So it's very efficient in terms of your disk utilization, as compared to other products where it would actually write one time to the disk for every time here. Similarly, when we're doing replication, right? If we have an HA setup, high availability, or we are using DR, we have alternate data centers, HA and DR is built into the product. Even if there's only one, if there's 50 different queues, I'm only sending out that data once across the network for HA and sending that data, that message only once across the network for DR. I've heard, I don't know if they've improved it, but in Rabbit, if there's 5 queues receiving that data, it's actually sending that message 5 times across the network to the other Rabbit brokers in the cluster as part of their kind of clustering solution. So very inefficient in terms of a fan out. But in Solace, we do fan out extremely well. It's all passed by reference. And so, our network utilization and our disk utilization is kept in check just because of these kind of, implementation choices here. So now, of course, you can add multiple subscriptions to queues. Think of a queue as kind of like, almost like a meta consumer. It's just a consumer that's running on the actual broker itself. And when the consumer connects, it doesn't need to specify these subscriptions. These can be added administratively by the the application architect, by the person who runs the Solace broker. This is typically how it's done in production. You'll pre-configure your queues. Of course, we also support dynamic queues creation. Consumers can create their own queues if they really want. But typically, queues are statically created, statically assigned subscriptions based on the topics that they know they want to receive. That way, the consumer, it just binds to that queue, connect to queue 1, and it just receives the data that has been kind of subscribed to it here. So queues can have multiple subscriptions. They can be subscribed to thousands of different subscriptions. But of course, because of wildcards, this one subscription here, training/greater than, can receive pretty much an infinite number of published topics. Anything that starts, the first level is training / whatever, ... will match and land in that particular queue. So one subscription equals many different topics. So this is by far the kind of best practice standard way of doing publish subscribe persistent delivery in Solace. Publishing on topics, ensuring that your delivery mode is set to persistent, and then your consumers binding to queues, and all of the kind of mapping, that queue topic to queue mapping, is handled inside the broker at an administrative level. Publish subscribe, super important. I'm actually going to be updating our samples, our Java samples that are currently online, and then kind of rolling out across the other APIs to promote this as the de facto way of doing persistent messaging with Solace. A lot of our APIs still kind of demonstrate publishing on a queue first. It is simpler. You just publish to a queue. You don't have to worry about adding subscriptions to that queue, even though it's really trivial. It's just like one step. But getting people to think about publishing on topics early on just really helps elevate the capabilities of their architecture later on. You can use queues for request reply if you really want to. Most of the time, request reply is done with non-persistent or direct messaging, simply because there's timeouts involved, right? If your producer, your requester makes a request, 5 seconds it hasn't heard a response, it probably sends it again. But if you want to guarantee that your data is not lost, you can always use queues. The consumer will be bound to a request queue here. The producer will be bound to a reply queue here. And that way, you know, you can guarantee even if during a failover or during a, you know, an outage or a, you know, whatever, that data will not be lost and the response will come. Oftentimes, you can use queues maybe if your response is very large, right? If you have a very large response, you need to send a bunch of data. You know, maybe you wanted to use a queue to help buffer that rather than using non-persistent or direct messaging and having the Solace NAB, the network card, buffer that data temporarily. Okay, what else can I show you really quickly? You know, if you haven't played with queues, this is probably the #1 important feature or configuration is the access type. And this specifies how multiple, what is the behavior of the queue in terms of data distribution, message distribution, when you have multiple consumers bound. So 2 types, the exclusive queue, right down here, and the non-exclusive queue. Now the exclusive queue provides an active standby mechanism. So the first consumer to bind to that queue gets exclusive access to the data. It starts receiving the messages. Every other consumer that binds to that queue thereafter is in a standby mode and won't receive any data until the active consumer either, you know, unbinds from the queue gracefully or ungracefully. You know, if the application throws an unchecked exception, you know, and basically drops its connection, this connection will drop, and the standby consumer will then activate. And there's actually, inside the Solace APIs, there's actually what's called an active flow notification event that says, hey, you've now been activated, get ready to receive the data from the queue. And the way that Solace also does, you know, with our acknowledgements, message acknowledgements, because this is persistent data, and anything that ends up in the queue becomes persistent data. Even if you are publishing direct messages and they land on a queue due to a subscription, it's what we call promotion. Once the data is in the queue, it is now treated as a guaranteed message and must now be acknowledged, act to be removed from that queue. So if the data is being streamed into this consumer and this consumer crashes, you know, it throws an unchecked exception or something, all of the data that had been sent to that consumer but not yet acknowledged is now resent to the standby consumer, the second consumer here, with a particular flag turned on inside the actual message, I guess, metadata. There's a Boolean flag called message redelivered, and the Solace broker will actually set that if the message has already been sent to a consumer and has not been acknowledged. So essentially trying to indicate, give a hint to a standby consumer that, hey, this message might have been processed before, might have been processed by another consumer, and perhaps the acknowledgement was lost. You know, if the acknowledgement was lost before, you know, before the connection, the acknowledgement didn't make it back to the broker before that connection dropped, then, you know, it's an indication to the consumer that that is happening. So that is exclusive queue. Non-exclusive queue is load balancing. We will round robin, the queue will round robin to any number of consumers that are connected. You could have 1,000 consumers connected to your queue, and the Solace broker will round robin between them. So that is how you use queues: persistent, round robining, load balancing, or active standby. Now, how are queues different than topic endpoints? Right. Before I talk about that, I will point you to this amazing blog. Let's just Google it. Topic, let's see, Solace, topic versus topic endpoint. Is that what I want? No, topic, endpoint versus queues. Ta-da! Understand Solace endpoints. This is it. This was written by my colleague Leah, I'm pretty sure. Is it? Yes. Leah, who used to be a trainer, and she knows, and before that worked in support, and is now a sales engineer for Solace, knows really a lot about Solace in depth. And so she wrote this awesome article here that explains exactly what I'm talking about here: topic endpoints versus queue endpoints, when to use them. The TLDR is, don't use topic endpoints unless you really, really know what you're doing, because 99% of the time, queues are better than topic endpoints and provide a superset of functionality, and we almost always recommend queues. Topic endpoints are only used in specific situations, usually around JMS migrations. If you need a direct subscriber, if you need specifically a direct subscriber, that is what the topic endpoint capability is for. It allows you to have a single topic subscription. You specify that topic subscription at bind time, So the endpoint itself doesn't attract messages to it until a client actually connects to it, a consumer actually connects to it. Whereas queues, you can have multiple subscriptions on there. You can have multiple ways of, you can have active standby consumers on there, the exclusive queue functionality. There's more capabilities in a queue than in the topic endpoint. So 9 times out of 10, if you're going to be doing persistent messaging, you're going to be using a queue endpoint with subscriptions added to it rather than a topic endpoint. It's just the name. People gravitate towards topic endpoint because they feel they need something that's topic-based. They don't really know that queues can have subscriptions right off the bat. This is kind of an issue that we have at Solace, is like when people start playing with it, they kind of go down these wrong paths of choosing topic endpoints. So almost never use a topic endpoint. That's the summary here. Well, that's my summary. I don't know if that's actually what Leah said. It's been a while since I've read this. Yes, selectors. That's a really good point. Okay, selectors. Selectors allow you to kind of like examine inside the message, but between the payload and the header, there's these application properties. It's a special section of the message that basically allows you to kind of perform additional filtering, kind of like a poor man's content routing. And it allows you to actually kind of look inside that. Now, because we support topic routing with hierarchies and some of the really good capabilities there, because we support that, topic routing. Yeah, there's often times that you don't need to use content routing. You don't need to use, these selectors. And generally, we recommend that if you can do your filtering using topics or certain levels of the topic hierarchy, we recommend doing that. But this is a really great blog to kind of examine what the difference is between a topic endpoint and a queue endpoint. And specifically what the difference is between a topic and a topic endpoint. Topics are metadata on a message. They're ephemeral. The publisher defines them when they publish a message. They come into the broker. They're used to examine. They're not a destination. They're not something that you configure inside the broker. Endpoints are. Endpoints are things that you configure in the broker to store messages for persistence. And the queue endpoint and the topic endpoint are the two types. But 9 times out of 10, 99 times out of 100 maybe even, I would say the queue endpoint is what you're going to be using than the topic endpoint, because it provides better functionality. That's kind of all I wanted to cover on this. Queues offer a ton of cool stuff. You can specify dead message queues, that if a message has problems processing it, you can move it to a dead message queue. So for example, TTL, right? If your message is only valid for 30 seconds or 20 minutes or whatever, the publisher can specify that on the message that there's a certain time to live. And at the end of that time to live, the message will either be expired to garbage, it'll basically be discarded, or you can actually move it to a special dead message queue. The dead message queue is just another queue, but you basically point to queue number 1 here inside its configuration to say this is the dead message queue. So it's just a second queue. And from there, you can have a special kind of error handling consumer. Typically, if a message ends up in your dead message queue, it's because something went wrong. The message wasn't processed fast enough, or something went wrong in terms of the delivery. The consumer that is reading from this dead message queue is typically a kind of an error handling consumer. So that is how you do it using TTL. Another really good use of TTL is in development environments. A lot of developers will publish on queues and kind of never get around to consuming them, right? They're just testing things out. And oftentimes you can run into situations where you have queues fill up and things can start to go wrong. If all of your queues fill up, basically you're going to be you'll be blocked from publishing more persistent data until you empty your queues. So oftentimes administrators will configure a TTL on the queues themselves in development to basically expire messages that are older than a day or something, right? Just to clean down the queues, to keep things tidy. I don't do this. I should do this. I actually log back into random brokers that I've started up, and I look in them, and there's queued messages from 3 months ago. Probably unnecessary, right? Just drain out your queues, or configure a TTL in development on your queues, and they'll automatically kind of just drain out. Another way that you can have messages end up in your DMQ is if they exceed the maximum number of redeliveries. So with persistent data, In Solace, it is at least once delivery, which means that until Solace gets an acknowledgement that a consumer has processed the message, it will continually redeliver the message until it gets that ACK. So if a consumer is constantly crashing when it receives that piece of data, the queue sends the piece of message, the data to the consumer crashes, maybe it's in the wrong format, maybe someone's published a bad formatted message, XML instead of JSON or something like that. The consumer doesn't have proper error handling, throws an exception, crashes out, the message goes back onto the queue, and when that consumer restarts, or if this is an HA configuration and consumer number 2 now connects into the queue, that message is resent. After 5 or 10 or 20 times of redeliveries, you know that message is going to just get stuck there. You can configure on each queue, a queue by queue basis, the maximum number of redelivery attempts. And so if and when a message is, surpasses that, let's say 15 messages, 15 delivery attempts, you can actually have the message either be discarded, probably not a good idea, or move to a dead message queue where you might log that or have some kind of special error handling consumer take care of it. So that is a really common pattern and usage for handling dead, poison pills and things like that. Now, one other cool kind of use of DMQs and TTLs is you can do delayed delivery with this thing, right? If you have a queue, say you want to delay a delivery of a message by a minute, right? Have the broker set up so that you publish a message into the broker, and a minute later it'll get sent to the consumer. This is how you do it. All you need to do is use 2 queues. You have queue number 1 set up here with a TTL of 60 seconds, okay? Then you have no consumers bound to it. You basically turn off, you can even disable the ability for consumers to connect to this queue. This is essentially the delay queue, right? Delay by 60 seconds, delay by a minute. At the end of that, the TTL kind of watcher will kick in, and it will expire that to a configured dead message queue. And this dead message queue, it's not necessarily a dead message queue. This is just where messages go that have expired out of your primary queue. This is where you have your active consumers listening. So rather than using this as kind of an error handling mechanism, if you set this up to be kind of a delayed message setup, then you have queue number 1 basically buffer that message for 60 seconds. At the end of that, it expires it to queue 2 here, and that is where your consumers actually connect into. So a really easy, cool way of doing delayed delivery in Solace. Okay, so that is that. Now, one last thing that we kind of ran into yesterday during our talk was how, during a persistent pub/sub kind of fan-out capability, what happens if one of the queues is full, right? So typically, if you're just publishing to a queue by name, and that queue fills up because the consumer is slow or the consumer has crashed, that queue fills up, eventually the producer, the publisher, will start to get errors, exceptions. We call them negative acknowledgements, or NACs in Solace. I think I don't think it's a Solace term. I think a lot of people call them NACs. So ACKs and NACs, right? The publisher, as part of its persistent publishing, every time a message lands on the queue successfully, it receives an ACK. If you're using JMS, if you're familiar with JMS, it's a blocking send, right? So when the publisher publishes something, the fact that the publish method, the send method returns successfully is the implicit ACK. And otherwise, it'll throw an exception, right? The send method will throw an exception. That is the NAC in JMS. But in Solace, because everything is asynchronous, ACKs and NACs come in on a separate thread. So you're publishing to a queue, one queue fills up, the publisher starts to get notifications that it's happened. But what happens in a publish-subscribe scenario, right? Here we have the producer. They're publishing on this particular topic. Now, this topic needs to be, again, publishing with the delivery mode of persistent, because if you're not publishing with persistent, you're using direct, and that's kind of best effort, right? That's fire and forget. There's no acknowledgements coming back from the broker when you're using direct messaging. It's kind of like multicast almost. So you're publishing with persistent. You have 3 queues here, Q1, Q2, Q3, that are all subscribed to that same topic, right? So that these subscriptions on these queues, each one will attract this particular topic that we're receiving here. And so what happens if Q3 is filled up? Well, what ends up happening is the the publisher will actually get a negative acknowledgement. It'll get a NAC. because at least one of the delivery destinations was full. And so this is by default. This is by default. You can change this behavior if you want to, if you really want to, possibly lose data. But Solace, the broker, is going to say, if I can't put it on everywhere, nobody will get it. And so what that essentially means is that consumers A and B here, these guys, they're fine. They are, they're keeping their queues drained out, but they actually will not get a copy of that message. If Solace cannot deliver it to everybody, it's an all or nothing style of delivery. If all of the queues can't take it, nobody will get it. The publisher at this point, receives a knack. Typically, behavior will, it's used to back pressure, right? It's used to back pressure the producer to say, okay, stop, maybe retry again in 5 seconds, or maybe publish somewhere else, or send an event, an error message somewhere. There's different, ways that the producer application can handle this. This is all business logic, essentially. This is what you do inside the API or inside the application space. The Solace API will not do the redeliveries in this particular scenario, right? Because it is kind of business logic. Solace APIs do not implement business logic. So if you have a situation where this consumer is crashed and you have, and this queue is filled up, the producer will start to receive negative acknowledgements, which will basically stop the flow of data from this producer, right? Because it can't publish. Typical behavior is the producer will go into a kind of a back off, and it will try again in 5 seconds, maybe then 10 seconds. It'll just keep trying until it receives, receives an acknowledgement. At this point, the operations people are running around trying to figure out why this queue is full. They're trying to figure out who the application team is to contact to get this thing restarted and to fill that up. But, all that to say, queues filling up in Solace is kind of, that there's been a number of things that have gone wrong in your application, in your monitoring, in your design, if you have queues filling up. Because, first of all, queues are used to buffer messages in the broker, right? How big do you make your queues? How much do you size your queues? Well, this is, part of application onboarding. And as a Solace engineer, when we work with application teams, we say, okay, well, how big do you want your queues to be? And they'll say, well, I don't know. How big should they be? Now, typically, queues are used to store data in case a consumer is offline or unable to receive the full rate of messages. So the how big to make a queue question essentially becomes, how many messages does this queue need to hold on to in the worst case scenario? And this is a function of your message rate. What's the average message rate? Let's say 1,000 messages a second, okay? Let's bring up the old calculator here, calc. Right, so let's say 1,000 messages a second is what my consumer is receiving on average. Maybe it's 500, maybe I get bursts up to 5,000. Doesn't really matter, we're looking at the average message rate. How big is each message? Let's say 500 bytes. Okay, so 500 bytes plus a bit of a header, plus some topics. Let's say 600 bytes, right? So that's how many bytes I am receiving per second, right? Let's say 3,600, that's per hour. So we're looking at 2 gigs per hour. And let's say, and then the next question is, okay, so that's per hour. How long can this consumer be offline for? What is the SLA? What is the applications team's SLA in terms of how, in case this consumer application crashes, how long does Solace need to buffer these messages until that consumer comes back? Is it 24 hours? Is it 8 hours? Is it just the length of one business day? Let's say it's 10 hours, just for argument, right? So times 10, 21 gigs. There we go. If this consumer, if we know that this is the message rate, 1,000 messages a second at 500 bytes, and it needs to be offline, it could be offline for a whole day. The development team can't get it restarted. Solace needs to be able to buffer a full day, 10 hours worth of messages. This is how big your queue needs to be, 21 gigs. Okay? So if your queue fills up, it's because you didn't size it properly. That means that this consumer, either your message rate is much higher than you thought, your message size is bigger than you thought, or this consumer is offline for longer than you thought. That is why this queue is filled up. So first thing that went wrong, you didn't size your queues properly. Second thing, I would argue, is that there are events, there are syslog alerts, notifications that are going out when this queue starts to fill up. Now, unfortunately, by default, in Solace, this high threshold warning is issued at the 80% mark. So in terms of the number of connections in your VPN, the number of subscriptions, the number of queues you've configured, blah, 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 message rates, all this stuff, the default high threshold is 80%. Now that's fine for most things, number of connections, number of subscriptions, because you assume that there's always going to be some connections and subscriptions during normal operation. You know, if your application normally has 50 connections, you know, maybe at the start of the day it spikes to like 60 or 70, that's fine. You know, if you hit 80, you know, so if 80 is your threshold, then yeah, I want to get a notification at 80. But with queues, typically when things are operating correctly, these queues should be empty. Queues are pretty much always empty. Basically, as soon as data comes into the queue, the data is getting read out of the queue. So your consumers, because your consumers are able to keep up with the publish rate. If they couldn't, then eventually, you know, you're going to fill up your queue. So things need to be sized in terms of rates. You know, a producer, if he's publishing way too much for one consumer, then you're going to have to start doing load balancing, some other stuff like that. So we've sized our queues such that, we've sized our consumers such that, you know, these queues when things are operating normally are pretty much empty, except for little transient bursts, right? So if I wait until 80% for my syslog alert, my networking monitoring alert to go out to my ops team, that is way too late, right? I'm waiting till my queue is 80% full. That's not good. You know, I only have 20% left to get that queue fixed up. So one of my #1 best practices for the ops people, for the admins, is when you create queues in Solace, change their notification, their threshold to be from 80 down to like 25 or 30 or 50 at the most, right? Your queue should not be filling up that much during normal operation. If they do, something is going wrong. Now, if you don't know where to find this, give me a second. I'll just really quickly show you. Let me get my tunnel here to the office configured. Dun, dun, dun. There we go. Go back to this. Localhost 8081. So this is the PubSub Plus Manager, also known as the Web GUI, the replacement for Solid Min that we're taking a look at here. Is it coming up? Yeah, there we go. Just a little bit slow. So this is a Solace broker that I have running inside my lab in the Singapore office. You can see it's a little bit old, 9.2. Let's just pop into my message VPN here, click on queues to look at all the queues. Good old Q1. See, I told you, there's a bunch of messages sitting in my queues. No real point. I don't know why. I should just delete those out. Settings. This is what you need to change. Click on Advanced Settings. Ta-da! This, Alert Threshold. Now, alerts can be sent out either over the message bus. You can actually subscribe to alerts as a messaging application. But typically, you have your management, your Elk and your Splunk and whatever else is listening to the syslog output of the broker. This is where the event gets raised. So this, edit, boom. These should all be, this should be like 10, and this should be like 25 or something. That is when the events get. Now in development, who cares, right? In development, I don't care. But this is in QA, in your production, especially your production. I think it's much better to give ops teams much more time to be able to call up the application team, because what is essentially happening is, as this queue is filling up, it's because this consumer, something's wrong with it, right? It's unable to keep up with the rate. It needs to be restarted, or additional load balanced instance needs to be started. So the ops team, the people monitoring Solace, will get this alert to say, hey, this queue is filling up. They need to then go and talk to the application team, whoever's responsible for this, to start up this, restart this consumer to start draining this queue. That is the kind of typical production, behavior that the Solace administrators would go through. And yeah, waiting until that queue is 80% full before I get a notification, that's bad. So these are some things about how queues and NACs and monitoring, and everything is done using Solace. Anyway, there we are. It is the top of the hour. It is just after 1 o'clock. I'm going to wrap this up. Thanks for watching. I hope if you're watching this in the future, I hope you found it useful. Be sure to come and say hi on Solace Community. I should probably actually give a quick refresh just to see if anybody posted anything up. And specifically on this, getting the destination name, the topic name in the Spring Cloud Stream binder, Matthew S. Sue, we are definitely going to find the answer for that. And I really hope it's something easy. Otherwise, that's a pretty big thing to get added to our capabilities there. Anyway, that's it from me. Aaron from Solace signing off. See you next week. See you next Tuesday. Same time, noon, Singapore time. Have a good one. Bye-bye.